So hi everybody, a little bit introduction about myself. My name is Rajendra Khirodkar. I came to Canada last year January. I joined Seneca Visual Effects and Film for Film and Television program at Seneca in January last year, and I got introduced to Houdini at that time. Being more interested in lighting, I really liked working in Houdini since the beginning, and after my graduation, which was in September, SideFX offered me an internship program here. So I quickly hopped in, joined here. And since then, I'm working on the terrain tools in Houdini. So let's get into terrain tools right now. Before actually starting with the presentation, I would like to show you some work I've done. So let's quickly have a look at it. So this was the island project where I used Houdini to create terrains, to create textures on this terrain, to scattering all the geometry, and to render. So for those of you who do not know what terrain tools in Houdini are, they are called as height fields. Height fields are basically 2D volumes, which are interpreted in your viewport like a geometry. And you can perform all kinds of volume operations on your height field to create the terrain look you want. So in the first part of the presentation, I'm going to introduce you to some of the more frequently used nodes, like these ones. And then in the later part, I will take you through the steps I've taken while I was working on the island project. So let's quickly dive into Houdini. Let's start with the very first node, which is Heightfield itself. So when you want to access any operational node in height fields, you just have to type HF, and it will show you all the nodes which are listed in that realm. So height field, this is the very first node you always start with. By default, it creates a 2D volume grid of 1000 meters by 1000 meters. You can see here, and it also creates two 2D volume primitives called as height and mask along with it. You can also call these as layers. The grid spacing on this node is like a resolution. So when your grid spacing is 2, your resolution will be 500 voxels by 500 voxels. If you reduce your grid spacing, you are going to increase your resolution. So it's now 1000 voxels by 1000 voxels. You can also change the division mode to bi-axis and specify exact resolution what you want. So if I specify 750, I can have that resolution now. This is in terms of voxels. Resolution of your height field at any point of the time is really important, because the effect of any operation you perform will be dependent on your resolution. And you can simply change that by dropping down a node called as Heightfield resample. And here you can specify exact resolution you want in terms of grid spacing or in terms of voxels. Let's move on to the next node. The next node is Heightfield noise. When you drop down Heightfield noise, it will create this vertical displacement on your height field according to the type of noise you use. The combined method on this node is like blending modes in Photoshop or in any compositing package where you can add, subtract, or multiply. You can see this effect when you have another Heightfield noise connected in chain. So when I add it, it will add the height value at the same location. And if I multiply it, you can get extreme results like that. Amplitude will decide how much, what is the amount of displacement you're doing. Element size is the size of noise pattern across your grid. So you can change the element size and get different results. Here in noise settings, you can choose among a bunch of noise options available in Houdini. Some of the more frequently used noise options I have listed here for your visualization. So you can see sparse convolution looks like this. Perlin noise will give you this result. Simplex noise. Here is volley F1 and somewhat mechanical volley F2 minus F1. One thing to observe here, this node has got two inputs. First input is for terrain and the second input is for mask. That takes us to our next nodes to talk about, which is masking features in Houdini, in Heightfields basically. You'll see this second input on a lot of operations to limit the effect of that operation to certain masked area. So how to create this mask? So the most simplest way to create this mask is you go on that node and if you see this paint node, if you click on this, whoa, it will take you too far. Not always though. So let's bring it near. And now you have your Heightfield paint node created here, but you don't have any mask information. So you can paint your mask with the help of your brush. I'm going to visualize mask. So by default, mask is always tinted with red color in Heightfields. And if you visualize your effect, you will get your noise pattern only limited to the masked area now. If you are getting these sharp edges here, you can put down a node Heightfield Mask Blur. And then you can blur this to get softer edges. Another node to create mask is Heightfield Draw Mask, where you can make a lasso selection to create mask. And there is Heightfield Project. So this node is basically more popularly used for projecting any geometry on your Heightfield. So when you drop down HF Project, and the second input goes to any primitive, you can see that. So I have a sphere here. You can see that sphere being projected on my Heightfield. But if you change the effecting layer to mask, it will create mask according to that. So now I can just change my change the position of my object and create mask according to that. There is one more way to create mask, and that is by using Heightfield noise. We just saw we use this node to create displacement. But again, if you change the noise layer to mask, you can create mask according to any certain type of noise you use. Along with all these nodes, there is one more procedural tool to create mask, which is one of my favorite nodes in Heightfields. So to show you that, I've created this terrain. The node is called as Heightfield Mask by feature. So when you put down this node, you get certain parameters here like slope, height, peak, valleys, direction, and occlusion. On the basis of these, you can create certain masks. So when I enable slope, I get minimum slope angle, maximum slope angle, and now I can include the value in between these in my mask. If I want only vertical faces, I can say I want between 50 degree to 90 degree. So this will be most steeper edges you're getting. So I've created some masks just to show you how it looks. So this is mask according to slope. This is mask according to height. Then again using curvature, using certain direction. So you can see you can spread 360 degree cone here and get any mask according to any direction. And finally occlusion. So these are all masking features in Heightfields, which are pretty useful. Masking is really important when you are dealing with creating terrains, because it is really responsible for creating different shapes in your terrain. Then again, it helps you with scattering different objects onto your terrain. And finally, even in shading and texturing part, mask will be really important things. Moving on to the next node, we'll discuss about Heightfield Distort. A lot of the times working in Heightfields, you will face the situation where you'll have to use some mechanical noises like volley F2 minus F1. And when we are creating something natural, which the straight lines doesn't go along with that in good way. So to break up these straight lines and give it a little bit more natural look, the best node to use is Heightfield Distort. We have two types of distortions available in Houdini. One is Heightfield Distort by noise, and another is Heightfield Distort by layer. As the name suggests, Heightfield Distort by noise uses two types of noise, curl noise and simplex noise, to give distortion to your terrain. And we have all basic settings like amplitude, element size on this. However, Heightfield Distort by noise uses noise, and Heightfield Distort by layer gives you the freedom to create the noise of your choice to distort your terrain. So here I've created three different types of noise. So this is one type of noise, and second and third. I put down a switch node, and I'm plugging that into the second input of Heightfield Distort by layer. And this is the result I'm getting after distortion. So this is first type, this is using second type, and this is using third type. On the first look, it doesn't look pretty, but believe me, when you are if you want to get a lot of feathering on your terrain when you erode it, this is the tool you want to use it. Let's talk about Heightfield Erode. As you all might know, erosion is basically removal of soil or rocks, basically removal of mass due to some natural agents like water or wind, and transporting that material getting transported to some other location. And to imitate the same effect in Heightfields, we have Heightfield Erode node. We already had Heightfield Erode since beginning, where Heightfields were introduced in Houdini. That was Houdini 16. But in Houdini 17, they have completely rewritten the tool and added a lot of new functionalities. Let me show you a video to just demonstrate the difference between two. So here you can see I have a Himalayan terrain. Actually, this is actual Himalayan terrain. On the very first frame, I don't have any erosion, and there is a erosion happening on both of the terrains in Houdini 16.5 and 17 for the same amount of frames and on by default settings. So let's see the result. This is after about 20 frames. You can see the erosion in Houdini 17 looks a lot natural than the Houdini 16.5 erosion. So let's see how erosion works in Heightfields. I would broken down our chain into two just to show you effect of erosion on two different resolutions. So in the first channel, in the first chain, we have 500 voxels by 500 voxels resolution terrain, and in second we have 2000 by 2000. So if I drop down Heightfield Erode, on the very first frame, I don't see anything happening other than these colors popping up. So let's go to visualization tab and switch off the colors for now. We don't see anything changing because erosion in Houdini is not a direct effect. It's basically a simulation. So to see the effect of erosion, you'll have to let it cook for some frames. So I'm going forward with the timeline now, and you can see some these edges are getting eroded here. Some flow lines are being formed. So at this point, now you can let it run for a longer time and let your terrain getting eroded. But if you like the result at any frame, you can simply go here and say freeze at this frame. And once you do that, now even if you scrub through timeline, your result will be intact. So let's talk about some options on the erosion erode node. On the main tab, you have some basic settings for like erodability and erosion rate for hydro and thermal erosion. On the second tab, advanced tab, you have a lot of new features added, which will let you fine tune your terrain to a lot greater extent details. I would recommend you to watch a master class from Erode, which was only specifically for Erode 2.0. He talks about it for around 2 hours, so it's pretty detailed video. And Erode, he's from SideFX. So let's go to Layers tab. Before that, I want to go back one node and get this. At this node, we can see we have 2 layers here, height and mask. And when we go down to Erode node, we can see a lot of new layers being added here. We have new layers like bedrock, sediment, debris, and water. So this Layers tab, it will let you keep or remove or reset the layers which are being created in the previous Erode node. So if you drop down another Erode node here and connect in the chain, so at this point you can say I do not want these layers created from in the previous node. So that choice is on this tab. Again, if you go forward on the simulation tab, you can get options for starting frame and allowing how much energy cache memory you want. Let's come to the visualization tab. You see these colors popping when you created this tab. Created this node, and if you click on compute range, this will calculate the actual elevation of your terrain, and it will assign this ramp from minimum to maximum elevation from left to right. So this yellow color will be assigned to the lowest elevation, and the white color will be assigned to your peak. You can also visualize different channels which are created as a result of this erosion node in different colors. So if I want to see my bedrock, I can say just show me in the red color or in any color for that matter. So I've ran this erosion for 21 frames and I'm visualizing it here. And on the other side, you can see here 21 frames. And on the other side, I'm running the same amount of erosion for 21 frames again. But this is on higher resolution. And you can see the difference here. You are getting a lot of details added on the higher resolution terrain. So that's when I said your resolution of your terrain is really important. Of course, you're gonna spend more time eroding your high resolution terrain. I have a habit of using Heightfield layer when it comes to adding result of erosion node on your terrain. So what I do is I connect my incoming terrain into the first input of Heightfield layer, and I connect my second eroded terrain in second input. Here what it enables me, when I use layer mode to blend, on 0, I get my input terrain. And when I do 1, I get this second eroded terrain. Now I can decide here, now I can keep control to myself how much of the erosion I want to add on this. So I think that's all about the erode node. Let's talk about scattering. So to show you how scattering works, I've created this small terrain here. Like Heightfield Erode node 2.0, Heightfield Scatter 2.0 is also a completely rewritten new node which is added in Houdini 17. We have 2 main problems in the old node. One was when we were adding new scatter points, our older scatter points were getting, their position was changing. So that was not always desired for artists. And the second problem was when you use old scatter node in cascade mode, it wouldn't recognize the points scattered in your previous node. So it will kind of create intersections between the geometries. Let me show you a video exactly to show you exactly what I meant. So here is Houdini 16.5. And I'm creating a mask here by putting down a node Heightfield pane. So this mask is being created, and as soon as I click on the Heightfield scatter node, I get points being scattered in that area. I'm copying some points, some spheres on those points just for to see it clearly. Now I'm changing my mask. I'm adding some more area into my mask, and now you can see all the points are getting changed. Their position is changing, and that's not always we want. We sometimes people will ask you like, oh, I like this result, keep this scattering, but add new points in some areas.
So would you fix that by having a second version?
Yes, no.
Second version, like scatter, completely separate.
Right. So we can have any number of Heightfield scatter nodes cascaded in your chain. So here is our terrain, and I'm going to visualize this is our basically our lake area, and your director asks you like, okay, you have to scatter a village in this area. So how would you go about that in Heightfield Scatter 2.0? I have actually downsampled our terrain just for faster processing. So first thing we need for scattering is a mask where we need to scatter the points. So we'll create mask by using Heightfield Mask by feature. Now I've created this mask, but we only need this area. I've created this by using the height of the terrain. And we only need this area, so I've created another node called Heightfield Draw Mask, and I've put it in multiply mode so that it will only keep whatever mask I've created in my previous node in this selected area. And now I'm dropping down a Heightfield Scatter node. So Heightfield Scatter node has three inputs. First is for terrain, second input is for mask or scatter points, and third input is for primitives. Let me show you some more parameters on this node. First thing we have here is tag name, which we have set to $OS, which is operator string. It means it will create an attribute called tag on the points being scattered on this in this node. So you can see if I visualize this node, I'm getting some points being scattered in this area, in our masked area. And if you go to geometry spreadsheet, you can see a tag attribute being created here. So we have houses attribute, which is created on each point. And this is going to be the base of our instancing workflow, the tag attribute. The next thing is scatter method. Let me go back to the sheets. We have 4 different scattering methods in Heightfield Scatter, out of which the top 3 will use a mask as the input and will scatter points in that. The difference is just that they have different parameters to control how many points to scatter. So by coverage, it will give you an coverage options like here. And you're getting a coverage option to control how many points you want to scatter. In the density, you get basically density channel. In total point count, you get how many exactly points you want to scatter in this area, so you can specify that. But the fourth method is different. It is per point count using source point. It takes already scattered points as input and scatter more points around it. So these were the points which were scattered in the previous node, and you can see all the other points are being scattered around those points. The next options are outer radius and fall off. So these two options are responsible for allowing intersections or not allowing intersections. So choice is up to you. Sometimes when you're scattering rocks, you want them to intersect and form some interesting shapes of other rocks. And sometimes when you're scattering houses or trees, you don't want them to intersect. So it's up to you. So here, when your radius is 1 and fall off is 0, you won't get any intersection. But if you allow, fall off is basically allowing intersections. And both these parameters work with together for that. Like if you have radius of, consider more radius than 1, but your fall off is in between, you still get basically intersections. Some other important options here are variability. This is P scale, which is responsible for the scale of your scattered primitives. So you can specify range here, which will, so now your points will have P scale from 0.7 to 0.8. Some other options are keep incoming scatter points. If you use another Heightfield scatter node in Cascade, you can choose not to keep the points which are scattered in the previous node. Then another thing is keep terrain. You can only keep points here. if you select these options, the terrain will not migrate along with your workflow. Then match normals with terrain. This is basically if your point is on some elevation, it will whether do you want it to match the normals with your terrain or not. And again the direction and slope. Randomize up, it will randomize. I think this will be more visible when I plug some trees here. So here I will plugged in some trees in the third input, and randomize up is basically it will randomize up direction. Randomize yaw is rotation, so you can randomize rotation here here itself. You don't have to create another attribute on scattered points. All right, so now we want to scatter some houses first. So I've created this basic house geometry which will scatter on the terrain. And I'm giving it that house geometry. Now our houses are scattered in that area. But it's not necessary that we want only one type of houses. We want multiple types of houses. So just to have a difference, I've created another house which is red color. And Heightfield scatter node is always listening to an attribute which is called as weight attribute. It's a primitive attribute, and here you can specify the percentage of your variants. So these are your two variants, house 1 and house 2, and you can create a weight attribute on it and specify how many of a specific variant type you want. So if I say house 1, I want 0.9%, which is 0.9, which will become 90% basically, and on other red house I have 0.1. And you can merge them together and plug that merge into your primitive input for Heightfield scatter. And now you can see both the houses are being scattered here. And also you can see percentage wise, red houses are really less numbered, so it's like 10%. All right, it's time to scatter some trees. So in the same way, I've created, I've taken the same mask for trees. And I have 3 different types, basically different colors tree, and I'm plugging that into here. So I'm getting this all 3 different colors trees being scattered here. Now I also want to scatter some rocks. So first I need, if you have different mask for rocks, you can plug that into, or if you are having the same mask, you can have that as an input. But here I have created another mask for rocks. Firstly, I'm using Heightfield Mask by feature and creating this mask on the basis of height and slope. Then in this node, I only wanted to scatter points along this edge of the lake, and I shrunk it down a little bit by using Heightfield Mask shrink. Again, I also had these flow lines coming from the terrain where usually rocks kind of flows from the terrain to downwards, right? Sure.
Why do you make sure that you don't houses and rocks from the side?
Okay, so that is already been taken care. Yeah, that's the feature of Heightfield, like scatter 2.0. Yeah, it doesn't matter. It won't. No. That you will decide with the help of radius. If you specify this radius as more.
You already scattered the point. There's not going to be a new point in the area.
No. So here you can see every house has a little bit it has a radius of this much, right? It's not getting intersected with other trees. So for the mask, I wanted to create some more, for rocks, I wanted to create some more mask which was in my debris channel. So here I used Wrangle to put the information in my debris channel into mask. So it's a very simple code actually. You just have to say @mask equal to @debris. And initially when my debris value was low, like the mask value in the debris channel was low, and I created this float channel here to multiply that. Because Heightfield Scatter is also looking for the basically value of your mask. If you have low value here, it will automatically scatter less number of points as compared to your one value. And again, as previously I used Heightfield layer to add two height fields. Here I am using the same Heightfield layer node to add two different masks, and this is my final mask. Also, my camera angle was this, so I wasn't going to see anything beyond these edges, right? For that, I created this, I drew basically a mask, and I got rid of all the area which was outside my visibility spectrum. And finally, my mask for rocks was ready. And here, I'm scattering rocks. Again, I also wanted to scatter some grass. So I used basically same. Let me show you the mask created for grass. So this was, again, we start with mask by feature. We again draw the area where I wanted to keep that. And I again painted out this area with 0 value because from the camera angle I wasn't able to see that area. So there's no point in scattering where you don't see anything. So here I'm scattering grass, and my bad. Let me show you from my camera angle, and you can see grass being scattered in this area. Houdini takes care of the fact that your viewport can't handle a lot of polys, but you can go in optimize and specify here how much of the poly count you want to visualize. So you can say I want to see 80 millions of polys, and now it is gone. Otherwise, it creates bounding box for those objects. And that's it. With the help of 4 scattering nodes, I created all my village. Now at this point, your director comes to you and say, that's all right, but I also need some houses in this area. I also need some trees in front of the camera. That's where the main feature of scatter comes in, where you add more scattering points and it doesn't change your old scatter, right? So let's see how that works. So basically what we will need to do is paint some more area in our trees and houses scatter. So at this point, I'm going to drop down HF paint, and I'm going to plug in our trees mask and houses mask. And I'm visualizing directly the result of trees and houses being scattered, right? So clicking on this node and painting some more area. Now you can see automatically, with our rules being followed, scattering is getting done. And there is no change on the other side. Your all scenery in the background is as it was. This can also be used in the other way, where your director tells you, like, we want some streets in the village. So you make your foreground value 0, and you just delete some mask, and you create streets in your village.
Seems to me though that the scatter process is all very procedural, but the road creation has to be manual.
That's creating mask is manual, right? That's because I'm showing you painting here, but usually you will create mask on the more procedurally as well. Because you will get the road maps, you will get some geometry for road maps, right? And you can basically use Heightfield project node to create mask on the basis of that geometry. So it won't be that manual, I guess. But of course, so this is basically allowing an artist, if you want to go if you want to go and paint stuff, or you want to use something else to create masks.
No, I get that, but say if you're randomly scattering all the houses and stuff, and then you can't have houses existing, no space, there needs to be some connection. You don't want to, like if the director keeps changing stuff, you don't want to have to be painting the road again and again and again.
Point I'm making here is to show you that even if you change your mask at any point of time, your points which are already scattered are not going to change. So that's the only thing, I guess. Did I get you, or do you have any other question? I'm sorry. Okay.
I have one question.
Sure.
Is there a way like you can have these masks from maps outside the Houdini, like we came to some other package and project on? Is there a way?
Yeah, sure. You can have that. So basically, if you bring in any image, right, and you can have that image projected on any plane, and you can delete on the basis of that. So it will keep only geometry, right? And then you can use Heightfield project node, which will project the same geometry on your Heightfield as a mask. So that is one way. Cool. So at this point, our terrain is actually a volume. It's not a geometry. So I'm choosing not to keep my terrain in this last node. We get a node called convert Heightfield, which you can plug in, and your Heightfield will be converted into geometry. So now these are polys. You can specify your density here, according to which your number of polys will depend on that. You can again say bake point color. So if you have any visualization on your terrain, it will keep that colors. I've disabled that, but let me enable it. So here what I'm doing is I created this mask for the rocks, and I copied it into another layer. So basically I'm creating another layer here by using Heightfield copy layer. I'm putting the mask information in rocks layer. I'm creating another noise with the help of Heightfield mask noise, and multiplying and adding that together. And so I created this mask, and I put down a Heightfield visualize node. This is the same visualization you get in Heightfield Erode node, where you can have a ramp mapped from your lowest elevation to highest. And again, you can color specific layers here. So this is the color I've got from there. And when I converted it, I get the same color, which is transferred as an attribute on the geometry. Again, whatever channels we had, they also become your attributes when you convert the terrain. And at this point, you can merge this both. You can take it to render, basically.
How do those visualizations render? They look?
Not that detail, of course, because they are just colors, right? Yeah. And this is not how we, of course, texture the terrain. Sure. And this is also not how we take it to output. I'll show you that in my Island project. Okay. Cool. So let's dive into the Island project. So when I was searching for some references for this, for doing a project, I came across this image, and I really liked it. This crescent and having a small island around this, and I wanted to create something like this. Not exactly, but having this crescent and some islands in the distance. So first thing was blocking. How would I block out my scene? So I started with Heightfield pattern node. Here I got this bump basically as a result of pattern node. Although this is not how it looks when you drop down. So when you say HF pattern, you'll get this. And you have to play with shape size and scale and post blur radius and again you can choose a different starriness and things like that. So this is like basic pattern I created first, and I distorted it. So I got this small rock-like structure, a small mountain basically, and I again created another pattern with another height and distorted it. And I used Heightfield layer to kind of merge that effect in maximum layer mode. So what it will do is it will keep the terrain whatever was on the highest maximum height. And I went on adding these kind of same structures to create my base. So if this was my camera angle, I went on adding some more mountains. I don't know what this blue is. Okay. I'm sorry for that. I think that's because we are recording with a device. So this was my basic structure created for that. Now at this point, I wanted to create a clear difference between my ground layer and basically bedrock. So I created a mask. This mask was created by using height. And actually I created this mask for ground and just clicked invert mask here. So it gave me this this mask here for bedrock. I blurred it a little bit and applied distortion on only mask. When you apply distortion, you get a lot of these rocky edges, kind of distorted edges, which will look more natural when we go forward. And I used Heightfield noise to lift my terrain from the ground. And at the end of this, I cleared this mask because I didn't need it anymore. I'm going to provide you this file, and I've also written down at every step what I've done and why I've done it, so it will be more clear for you. At this point, it was time for steeper erosion. Steeper erosion is basically erosion on lower resolution. In this Heightfield workflow, we start from very low resolution, like 500 voxels by 500 voxels, and we go on adding our resolution and doing more erosions. So this was our first erosion pass, which usually gets us more steeper result. So I have resampled my terrain down to 500 voxels, and I'm doing this erosion pass here. So this was the result I got at the end of this. I got this good flow lines happening here. And again, as I told you before, I like to have control in my hands how much of the erosion I want to keep. So from the one side, I got my original terrain, and from the second side, I got the eroded terrain, and I kind of kept it a 0.35 value which was desirable for me. After that, I wanted to add some terracing effect. If you might have seen at some terrains, this is the terracing effect we see in some of the mountains. And to imitate this in Heightfields, we have a Heightfield terrace node. It needs a mask, so I created mask here with the help of, again, mask by features. This is mask by feature is the node you'll like 90% you'll use it for creating the mask, because it is procedural. Even if you go prior to these nodes and change values, it's still gonna keep that same elevation and all. At this point, I distorted my mask and I applied Heightfield terrace. So this is the effect it created. You can see this terracing from the top angle properly. Again, I didn't want to have only one type of terracing, so I created another mask in some other areas just to have a random terracing. So this was basically less step size terrace. In this terracing, you get basically two options are important. One is terrace step size, which will decide the size of your terrace step, and smooth edges. So if you go on decreasing your size, you need to decrease your smooth edges as well to get this proper smoothing at the edge of your terrace, at the edge of your steps. And at this point, I created a mask and used Heightfield layer to add both of these terracing. Right, so this was the end result I got. I also wanted to have some slumping happening at the bottom. Slumping is basically when your debris and mass of the terrain, basically soil, is coming down and it gets precipitated at the horizontal level, and it forms these kind of shapes, right? So this effect is called as slumping, and we have a Heightfield slump node to imitate that one. So here I distorted my terrain a little bit, and I created mask for slumping because I only wanted slumping at the bottom. And you can see as a result of it, I got this mask being precipitated at the bottom. At the end of it, I cleared this mask. A Heightfield slump is really very useful when you are creating some snowy mountains or also deserts. It will give you the same feel if you create, like, this area will serve you as snows, and these vertical faces will be rocks popping out of the snow area. Now it was time for mid-level erosion. So to add more details, I resampled my terrain to 1000 by 1000 voxels, and I again eroded it. Now as you go down the line and you are resampling your terrain to higher resolution, you will see the time for erosion will keep increase. And I have a habit of putting down a resample node after each erosion, because as a result of this erosion, I've seen we kind of get this jagged edges result. So I just upsample it to a little bit higher resolution. So here I am at 2000 by 2000 voxels. Here I was also getting some, even after resampling, I was getting some jagged edges in the debris channel. So I wanted to blur those edges. I created mask for that, and I blurred that mask. And I again put down Heightfield blur node to get some softer areas in that. And again, like previously, I added Heightfield layer node and decided how much of the erosion I wanted to keep. So after my final erosion, I again got this result. At this point, my terrain was almost finished. I wanted to create this kind of a lower elevation in this area to kind of show this is a beach area, and it's kind of going down in the water, over the water surface. So I created mask for that area and used Heightfield remap to take that area a little bit at low elevation. And finally, I resampled my terrain to have 5000 voxels by 5000 voxels. This is pretty high resolution, so when you convert it, I have value density of 0.5. Now for rendering this terrain, you have two different options. Like you can convert it into a geometry and take it to any other package, or it doesn't have, Houdini doesn't keeps any dependency on this. So you can take it to any third-party software and render it. Another way, which is more often seen, is exporting out maps. So you can export out height maps and masks for different channels, and then use that height map for the render time displacement. And for doing that, we have Heightfield output node in Houdini. In this node, we specify file name. Then in format, you can specify RGB or single channel, and specify your resolution. And in these channels, you put the information you want. You can also have a kind of hybrid Heightfield output, where you can put one value in one channel and different value in different, so that you can save space basically. So I created this Heightfield mask. Let me show you how it looks. And this is the height map I exported out of that terrain. And you can use this to basically have a grid and displace it at render time. Then again, for texturing purposes, I created this texture, this mask. So my first mask was for rocks, and rocks, I wanted to keep rocky region where I had very steep areas, very vertical faces. So I created this mask where I specified I want the faces which have more than 38 degrees and till 90 degrees. And I applied a small blur on it so that when my another texture will come in, it should blend it with properly. Likewise, I created mask for grass, and again mask for flow lines. Flow lines is basically one of the channels get created as a result of erode. So I put that information. I took this information from sediment layer actually, and I put it into mask. So it will show you in red color, and I exported that out. So this was my flow line mask. Again, the grass mask, and mask for rocks. And I'm going to use this to apply different textures on the terrain geometry. After this point, let me show you how I created material for this. So I'm bringing in my poly-reduced geometry here, and as you can see, if you go in UVs, it when you convert your height field, it basically projects UVs from the Y direction. So you will get your UVs perfectly in your first UDIM. And this is my material setup for the terrain. So what's happening here is I'm using a material blender to blend different materials. In the base color, I've applied a material for sand. So this was rendered from my camera, and I only had geometry here, without any material. And this is when I applied sand material on it. But I only wanted to keep sand material in this area, in the beach area. So after that, I created another material for rocks. So basically it's like this. You will have only sand material now, and this is rock material. And I'll plug it in the second layer. And again, I will use, in the place of blend color, I will use the mask I created for rocks. So as a result of this, you will get this result. So this was my mask for the rocks, and this was my result after getting rocks material getting applied. Again, after that, I plugged in mask for grass material, which I had this mask, and I rendered with this. So now I have both materials applied, rocks and grass. After that, I also wanted to add some flow lines here. So I already had a flow line mask created. So here I applied that material, and you can see I have different material in flow lines. So materials, I've explained you how materials are created for this. Now it was time for scattering. So I brought in my terrain in another geometry container. So this was my created terrain, and here I created mask for trees. Here I wanted to have less density of trees spread on the top edges. So I had a mask where I had less value in there, and so this was my base mask. I did not want any tree to be scattered in the flow lines. So I deleted that area from my mask just by simply saying mask equal to mask minus water. So it got rid of that water channels. And as a result of this, I was missing some interesting area on this edge. So I explicitly created that in the mask, and I merged that with the help of Heightfield layer node. And I get these points scattered on this. Let me show you when I attach the geometry. So here I get my all the trees being scattered on this terrain. After that, I also wanted to scatter some points in the rock in the beach area. So if you go forward with the camera, you get this beach area exposed. So I created mask for that, and I put some more rocks there with the help of another Heightfield scatter node. So at this point, I had both my rocks and trees being scattered. I can also have grass, but as my camera distance, it wouldn't seem to have a good decision to have grass scattered, because it wasn't in any way going to be visible that clearly. But you do not want to render this way, because this becomes a lot heavy in terms of calculation. So I wanted to get only points out from here. At this point, on my last node of scattering, I had like million points available for different objects being scattered there, and I also have a lot of different attributes here. So I put down an attribute delete and got rid of all the unwanted attributes, and I wanted to instance different objects on that on those points. So let me show you how instancing works in Houdini. So if you have a sphere, and you want to scatter this basically instance this sphere on bunch of points, so you get an instance node. The way instance node works is you need to have points inside it. So add nodes, create one point. I'll delete it and create a grid and scatter a bunch of points on it. So now our points are ready for scattering. Let me have some less points, like 20. And on this instance node, you can specify which object you want to scatter, instance. The instancing works only in object level. It doesn't take any input from SOP level. So you can only specify any geometry container here. You can't go to the actual out node or anything. So I'll have to specify sphere 1, and at point instancing, I'll say full instancing. So I get these spheres being instanced on this point. And if you want to move any one of these spheres, you can't do that, because this only exists at render time. This doesn't actually exist in your viewports. Like if you take the same sphere and do copy to points, and if you want to select any one of them, and if you want to move that, you can actually do that, but not with instancing. They only exist at render time. So I put down an instancing node, and I got all my points inside it. The way instance node works is it is always listening to an attribute called as instance. So I wanted to do what I wanted to do was create an instance attribute which will tell which objects are to be instanced on those points. So I put down a node create attribute. The name of my attribute was instance. Class is point attributes, and the type of that attribute is string, where we specify which object should be instanced. And you can see here I use this tag which was created as a result of Heightfield scatter node to specify what geometry container I need to instance on trees points, what geometry container I need to instance for on rock points. So at this point, I had 4 different types of trees, and I had same nomenclature wise, I had same text till this point in each of the trees. Only 1, 2, 3, and 4 was the different points. So I specified this string here till my common text, and I put down this floor function to have the different values on each point, on each random point, so that it will pick up all the 4 trees randomly on each point. And similarly, I created that instance attribute on rocks. So if you go down, you can see these values here. I have randomly different trees being assigned on different points. Again, I brought back some more freedom to choose p-scale attribute at the. Sometimes when you are rendering, you realize that, oh, my trees are smaller. My like there is some scale changes needs to happen. So I created a channel to multiply your p-scale, and I brought back it on your main instance node so that you can decide at that time if you want to change the p-scale. And I'm using this wrangle to get rid of the points which are not in the camera frustum. So like that. And when I visualize this node, it will take a minute, but it will create all the instance geometries, and it will render way faster. So that was around million points, and I also had 2 different islands. So about 2 million objects being scattered, and my render time was around 15 to 20 minutes per frame. So that's a pretty good time, I think, for that. Again, if you observe in my render, the rock details here doesn't look that good. Like they just look like plain textures on that. So I wasn't happy about it, and recently I worked out a workaround for that. So let me show you that. So here's what I did. That's Houdini, right? It starts cooking as soon as you enter. Yes. So here we are. So this was my rock geometry. I wanted to have more details onto, right? And the way Convert Heightfield works is it creates UVs only from y-axis. So on these vertical faces, you will definitely have a lot of stretching happening. So what I did was I deleted a lot of unwanted layers from here. So this is a funny thing because this node is used for SOPs, a delete node. And for a long time, I was struggling with this thing, how to get rid of unwanted layers from here if I don't want to use it again. And it never occurred to me that a SOP node would work with height fields, because those are volumes basically. But one thing I learned while working with Houdini is to keep an open mind, because anything can happen here. So one of the developers told me that this SOP node works to delete volumes as well. So you just have to specify name of this layer, and it will get rid of that. So here I got rid of all the layers, and what I'm doing here is I'm creating masks on the basis of different directions. Because my faces are mostly vertical, what I can do is I can create masks from all the 4 directions and project UVs from all the sides to have good UVs basically. So I'm creating this mask from one direction, and I'm creating, I'm adding that mask in my main height field, and I'm copying that to a new layer called positive X, and I'm doing same from all the directions: positive X, positive Y, Z, and negative Z. So at the end of it, I have 4 different directions, mask for 4 different directions. And here at this point, you can see I have different layers. And I converted my height field to geometry here, but still I have all those layers as an attribute on my points. So at this point, I'm deleting and keeping only the geometry which was from positive Z here, negative Z. And this all operation is happening on points, so it might take you some time. Yeah, I did. I tried it putting a group here, but when you have a group, it basically has some overlapping faces which are shared. So you have a problem with that with the UVs. And now on each of these faces, I'm projecting UVs from that particular axis. So at the end of it, when I'm merging all the points together, I'm again using add swap to get rid of these unused points here. But in UV quick shade, you can see you get a very perfect kind of UVs here.
So why aren't you using the triplanar?
I could use triplanar, but I've seen it's not giving me that because you have to use triplanar in displacement as well, right? And I haven't seen any, like displacement wise, I can't use triplanar. Yeah. At this point, I am creating a group for outer edges. And I'm then applying two different materials, one for outer edges, which is without displacement, and one for all the inner geometries, which is with the displacement, so that for the outer edges, it will keep this entire geometry intact, and it will basically merge with your original terrain. So only internal these interior faces will be extruded as in rocks. So at the end of it, I'm getting these really good rock details, and now you can just change any material, put displacement on that, and have different kinds of rocks even popping out of your terrain. So this method allowed me to have these good kind of details on this. You can also have a noise on this material as a mask to have different kind of different tile textures basically. So some of the region will have more tiling, so that it will not look so uniform. And at this point, I have all this geometry here, which is visible, and both of my instancing, and then that's it. I hit render. So that's all, guys. I hope I didn't bore you too much, but it's a lot of technical information, and I would really recommend you to go and watch. One is masterclass from Erode. Another is again his masterclass for scattering as well, and third video when Heightfields were introduced in Houdini first, in Houdini 16. There is a masterclass from Jeff Lett. I would recommend you to watch these 3 videos to get to know more of Heightfields. You can also go to a website called as Open Topography, and from here you can basically get this height data. You can select the region you want, and you can get this height data exported out. You have to create an account on this website, so and they will send you that data as email. And you can take that file and put down a Heightfield file node, and this will basically give you the same exact terrain geometry, terrain volume as that area. So that is one thing that Jeff Lett has explained in his video. So I would recommend you to watch that as well. So cool. Thank you very much for coming in and bearing me for 1 hour. Thanks. Do you guys have any questions? I didn't ask actually. Sure. Yeah, sure.
So is there any way to do it on anything other than a square?
Oh.
You want to do a Heightfield on a circle, for example, instead, because the harsh edges of a square kind of.
Sure.
If you want to see the whole thing.
Let me show you one thing for that. In Heightfield 17.5, they recently add this feature where you need not to have any square geometry now. You can just have any mask, and you can cut out that Heightfield, and you can have any shape.
So how do you cut that? So it's disconnected.
Yeah. Let me show you that.
Is that just another node?
No, it's like as I created mask for by using an object, you have Heightfield project node, right? Yeah. So you have Heightfield cutout by object node, where you can cut out by object, but it is available in Houdini 17.5 because it's only in the recent version. and you can just plug that into the second input of cutout by object, and it will only keep the area which is covered by that object. So now you know more how that dependency of square height fields. Yeah. Right, guys. Thank you very much.